Welcome back, Algebra 2 students. Today we're going to be looking at linear programming, which is a supplemental lesson, so it is not in your textbooks. So you do need to watch this podcast rather than take notes out of your book. Linear programming is solving real-world problems by graphing systems of linear inequalities to find maximum and minimum values in a feasible region. We have to find constraints, which are inequalities. The feasible region that I mentioned is the solution to the system of inequalities. So you've already graphed systems of inequalities. The feasible region is going to be that region that was shaded. The vertices are your corner points of the feasible region, so these would be your points of intersection of the two lines that create that corner. And then you have an objective function. The objective function is the function that maximizes profit or minimizes cost, or it can maximize income, so on and so forth. Here in our first example, we're going to graph this system of inequalities, and we're basically going to go through the whole process of graphing and finding our feasible region. Alright, we're going to go ahead and we're going to graph these inequalities. And the first one that I want to graph is x is greater than or equal to 1. So I want a vertical line at x is 1. And remember, we're going to shade that inequality. So I have my vertical line here. Did I make a mistake?
No, I was just going to change color so I could see it.
Oh, okay. And then I want to shade what's greater than or equal to that, so I'm going to eventually shade to the right of this line, but I'm going to do that in just a minute after I have all three of my inequalities shaded, or graphed, excuse me. So now I'm going to graph the second inequality, which is y is greater than or equal to 0, and I know that's a horizontal line on my x-axis. So there is my y equals 0, and I'm going to shade what's greater than or equal to that, so I would shade everything that's above that. And again, I'll shade in just a minute after I get my third line graphed. So my third line, 2x plus y is less than or equal to 6. I'm going to find my x-intercept by putting a 0 in for the y, so I get my x-intercept to be at 3. Which is here, and then I'm going to put a 0 in for the x to find my y-intercept, which would be at 6, which would be here, and then we're going to draw our line, and I want to shade everything that is less than that line, and everything that is less than that line would be kind of below it or towards the left. So if I want to shade all of those directions, all of those parts, my feasible region or shaded area would be inside this triangle. So that is what we call our feasible region. It's the shaded area. The next thing I want to do is I want to find the coordinates of my vertices. Now the vertices that I want to talk about are my points of intersection. So I've got a vertex here, and a vertex here. This point is rather obvious. That vertex would be at 3, 0. And then we have a second vertex here, which again is a little more obvious, and that one is at 1, 0. But our third vertex up here at the top is maybe a little more difficult to find, and this is why we've been studying finding points of intersection. So I'm going to actually calculate that point of intersection by looking at the two lines that intersect. And if you look at the colors I used compared to the arrows that I drew by the inequalities, then you'll know which two inequalities I graphed. So I graphed this inequality and this inequality to create that point of intersection. So I'm going to use those two to solve and find the point of intersection. So I'm just going to pretend like this one says x equals 1, and I'm going to substitute my x into my third inequality to find my y value. So I'm going to have 2 times 1 plus y is equal to 6. If I subtract 2 from both sides, I have y is equal to 4. So I know my third point is at 1, 4. Now it doesn't look exactly like that because of human error, but my point is at 1, 4. The next thing I want to do is I want to find my minimum and my maximum values. And to find the minimum and maximum value, I have to use the function that I have written up here in the question in red. Now I wrote that function in red because it's very important. It's always going to help you find your minimum or your maximum value. So what I want to do now is I want to take the coordinates of the vertices that I found in step 2 and I want to plug them into this function. F of xy is equal to 3x plus y, and I want to figure out which one's going to give me my maximum number and which one's going to give me my minimum number. So I'm just going to do that. I'm going to take each one at a time. So I've got 3 times 3 plus 0 using the first coordinate. So I get 9. And then if I do the second coordinate, which is 1, 0, I would get 3 times 1 plus 0. So I'm going to get 3. And then if I use my third coordinate, which is here in red, I would have 3 times 1 plus 4. So that gives me 3 plus 4, which is 7. So all I need to do is look at those 3 values that I just calculated and determine which is the maximum number and which one is the minimum number. So those values were 3, 7, and 9. So my maximum value would be 9. My minimum value would be 3. Now we want to actually go ahead and take a look at an application problem. So this story problem looks rather lengthy. There are steps that you want to go through to do this, and we are going to show you each individual step that you need to go through. A landscaping company has crews who mow lawns and prune shrubbery. The company schedules 1 hour for mowing jobs and 3 hours for pruning jobs. Each crew is scheduled for no more than 2 pruning jobs per day. Each crew's schedule is set up for a maximum of 9 hours per day. On the average, the charge for mowing the lawn is $40 and the charge for pruning shrubbery is $120. Notice that statement I just read is in red. That's because that is similar to the last function that you saw in red. It's a very important function or statement. Find a combination of mowing lawns and pruning shrubbery that will maximize the income the company receives per day. So my first step is to define my variables. This is the first step you want to do every time. And again, if you go step by step in this process, this will work out quite nicely for you, and you'll find it easy. Yeah, you're going to be successful if you follow these steps. So the first thing I want to do is, again, define my variables. So I'm going to use letters that make sense to me. So I'm going to use M is equal to the number of mowing jobs. And then I'm going to let...
You might want to write above because I think the next one's
going
to come in a little close.
I'm going to write the next one above so that we don't write over top of things. So I'm going to let S equal the number of pruning jobs.
Can we change that to a P?
Yeah,
P for pruning jobs?
that's a good idea. I think I put S for shrubbery, but let's change that to a P. So let's have P is equal to the number of pruning jobs. Okay, so I've defined my variables. Our next step is to write a system of inequalities. These are called your constraints. Now the constraints are very important because that's what you're going to use to graph and find your feasible region. So on this particular problem, what I want to do is I want to look at what information am I given. Here in this statement, I know it takes 1 hour for mowing jobs and 3 hours for pruning jobs. And if I look here, I'm only working 9 hours per day. So my 1 hour for mowing plus my 3 hours for pruning jobs has to be less than or equal to the 9 hours that I have available. There's one of my constraints. Now if I continue reading, I see here that I only schedule 2 pruning jobs per day. So there's another constraint. P has to be less than or equal to 2 because I only schedule 2 or fewer of those per day. In addition, there's 2 other constraints that are not written in the problem, but they are assumed. Because this is an actual application problem, we're working in the first quadrant, so you want to go ahead and say that your mowing has to be greater than or equal to 0, and your pruning has to be greater than or equal to 0. So these 2 last constraints that I just wrote tell me that I'm always going to be in the first quadrant. And those are some easy points, so be sure to put those on each of these linear programming problems. All right, so the next step is just to take a look and see that I have mowing jobs and pruning jobs, and then here's my constraints again. My next step is to graph the system. So I'm going to graph each of these constraints just as we did in example 1.
So, Ms. Preston, really quickly, this is the exact same problem that we just did. They don't need to recopy this problem. This is just a continuation of the last problem, correct?
Right, because there are several steps to these problems, and it's impossible to get them all on one screen, so we use several screens. So again, the story problem is the same. You don't have to recopy it. I'm just continuing on to a different screen. Okay? So let's graph these constraints. I have the mowing has to be greater than or equal to 0. So I'm going to go ahead and I'm going to put my these 2 constraints on my graph, and that happens to be my x-axis. So this is my mowing, and I'm going to use my pruning as my y-axis. And it actually doesn't matter which axes you use, because these 2 are not dependent on each other. So you can assign whichever one you want to the x-axis and whichever one you want to the y-axis. So now if I graph this constraint, that's going to be my y-axis. And then I'm going to go ahead and graph this inequality. M plus 3p is less than or equal to 9. So my m-intercept, or my x-intercept, is going to be 9. So that's a point out here. And my p-intercept, or y-intercept, is going to be 3, because 9 divided by 3 is 3. Okay, so I'm going to draw that line. Now remember, I am going to be doing some shading in a minute, but I like to draw in all of my lines before I do the shading, because I like to be able to see my lines. And if you shade, that sometimes inhibits you from finding a point. My 4th constraint is the p is less than or equal to 2, and since that's my y, I know that's going to be a horizontal line at 2, so I know that's going to be right here. Okay, so now I want to shade this region. Okay, and this gets to be a little tricky when you have all these lines on here. But let's take a look. I want to shade what is greater than my horizontal line at 0. So I want to shade above this blue line. Okay, and then I want to shade what is greater than or equal to my red line. So that would be to the right. Then my black line, the m plus 3p is less than or equal to 9. I want to shade what's less than that line, and that's going to be what's below it. And again, with your 4 constraints, this gets really tricky to see. But I'm going to continue, and I have to do this fourth one. P is less than or equal to 2. And again, that was my horizontal line. And so I want everything that's less than this horizontal line at 2. And again, it's a little tricky to see, but hopefully you can see this region. I'm going to outline it the best I can in black, and then we'll shade it in.
And if they have an eraser, they can erase all but what is shaded in.
Right, and that's a good idea too, is to erase everything but what is shaded in. So my shaded region is this trapezoid right here. Now you want to be careful on this one because it's not a triangle, it is a trapezoid. Alright, so I now need to find my constraints. Oh, right. Actually, sorry, my vertices. I already did my constraints. So I want to find the coordinates of the vertices. So I have a vertex here, 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 and here. Now again, just like last time, some of these points are easier to find than others. This point, of course, is at 0, 0. My second point, if you can count, that's at 1, 2. So 0, 2. This point right here, I'm going to save that one for last because I'm not really sure. There might be some human error, and I might not have that exact point of intersection, so I'm going to calculate it. My fourth point over here, I know was my x-intercept at 9, so that point is 0, 9.
Or 9, 0, like you wrote.
Right, which is 9, 0, which is exactly what I wrote. Sorry about that. Okay, so good thing Miss Smith's here to correct me when I make those mistakes. I do want to find that fourth coordinate, or that fourth vertice, and I want to do that by using the 2 lines that intersected. And again, if I look at the colors I used, I know that this m plus 3p is less than or equal to 9, and this p is less than or equal to 2 are the 2 lines that created that point. So I'm going to use those 2 inequalities to find the point of intersection. But I'm going to just pretend like they're equations for right now. So I'm going to have p is equal to 2, and I'm going to have m plus 3p is equal to 9. So in this case, since I already know p is equal to 2, I'm just going to use substitution. And if I substitute that
in your head.
2 in there, yes, you should be able to do that in your head. If I substitute that 2 in there, I get a 6, so my m would equal 3. So my third point, my m value is my x, so that's going to be at 3, 2. And I think I said that was my third point, but it's technically my fourth. Okay, so I found all of the vertices of my feasible region. So I want to go...
We need to save all that room. We got a clean screen.
Got a clean screen? What do you know? Alright, so I found all those points. Those were my vertices. And again, this is the same question. You don't have to rewrite it. We're just going on to the next step. My fifth step is to write my objective function. And hopefully you remember from example 1, my objective function was written in red on example 1, and it's written in red again here on example 2. Now again, the objective function always is going to deal with your maximum. What do we want to find the maximum of? Well, we want to find the maximum income, and that's money. So in this particular example, you have to look for the statement that talks about money, and I have circled that in red, and it's written in red. So I want to maximize my income, so here's my my income function. So the income is going to be a function of x and y, and it's going to equal... You didn't catch my mistake there. It's got to be m and p. It's going to be a function of m and p rather than x and y, because those are the variables I used. and I need to write the function. How do I maximize income? Well, if I get $40 average per lawn or per mowing job, that's going to mean I take 40 times the number of mowing jobs I have, and I get an average of 120 for pruning shrubbery. So I'm going to add that to my mowing. So my income function is I of MP is equal to 40M plus 120P. So there is my objective function. In step 6, what you want to do is you want to take those vertices that we found on the last screen, the same exact vertices, and you want to substitute them into this function that we just wrote, and we want to answer our question. So our question says maximize. So we're going to substitute those points in, and we're going to find our maximum value. Okay, now let's take a look. Let's do one point at a time. So the first vertice I had was 0, 0. Now let's think about this. If you do not mow any lawns and you do not prune any shrubbery, unless you're magic, you're not making any money. So this is 0. Okay? You don't even have to do the math there. Use your brain. The second point was at 0, 2. And so I'm going to substitute that in there. If I don't mow any lawns, I'm going to have $0 there. But if I do 2 pruning jobs, I'm going to have 120 times 2, which would be 240. So my profit or my income here would be $240. And again, all I'm doing is substituting these points into my income function for the M and the P. Let's try the third one. My third point is 9, 0. So again, if I substitute that in there, I have 40 times 9 plus, I'm going to get 120 times 0. Again, use your brain, use your noggin. That gives you 0. 40 times 9 would be 360. So I have $360. The fourth point was at 3, 2. I'm going to substitute that in there. This one I actually have to do a little bit of work on. So I have 40 times 3 plus 120 times 2. 40 times 3 is 120. 120 times 2 is 240. So I have 120 plus 240 is going to give me 360. So my income here is 360. Now again, we wanted to find the maximum. So I need to look those over a little bit and do some thinking. And I want to find the maximum. I'm not sure, is it going to go to the next screen?
Yeah.
Or? Okay.
No,
Okay, so
it's not. We go ahead
it's
and
not.
have
Okay.
number 7. So if we,
Okay, so we have step number 7. Oh, there it is. So I'm looking at these. Which one is my maximum income? Well, here I have an income of 360, and here I have an income of 360. Now I need to answer this question here, and I need to explain my results. So I would state that my maximum income is $360.
remembering that word problems deserve word answers.
Yes.
That's the reason you're writing this all out.
And I did write a sentence there exactly like Miss Smith said, word problems deserve a word answer. So now I need to explain that. What happens, what are you doing to get that income of $360? Well, in this particular problem, there's two different types or two different points that give us the $360. So my answer, I don't know if I have enough space for writing it here, but
It didn't save our changes.
it didn't. Oh, I can explain to you why in just a minute. That means we're going to have a question that's wrong in a little bit that we have to change.
Okay.
Okay, that's a bummer. Sorry, back to this question. Let's explain our results here. So you should be writing this in a sentence, and again, I don't have enough space here to write this, so I'm just going to tell you what type of thing you should be writing. I then would create a sentence that says, to reach the maximum profit, or excuse me, the maximum income of $360, you can do 9 mowing jobs and 0 pruning jobs, which would be this case, or you can do 3 mowing jobs and 2 pruning jobs, which would be this case.
So it really doesn't matter. They use their own words here, right? And it doesn't. They just need to explain it. There's not a right or wrong sentence. It's
Right.
just
The
their own
sentence
words.
is not right or wrong. It's your own words. Explain to me where the $360 is coming from. What types of things do you have to do to get the $360? Okay? And as we said a minute ago, I think we're going on to example 3, and we're going to have a typo in example 3.
Okay, I don't think we want to go on to example 3 because we're already at 26 minutes.
I think we're going to pause for a minute. Okay, we're going to go ahead and stop then. And we will continue with a second podcast next time.